questions 11 through 20 on the 2007 grade 10 Cayley math contest. Ivan trained for a cross-country meet. Cross-country is running. I used to be and still am a runner. On Monday, he ran a certain distance. On Tuesday, he ran twice as far as he ran on Monday. Wednesday, he ran half as far as he ran on Tuesday. Thursday, he ran half as far as he ran on Wednesday. Friday, he ran twice as far as he ran on Thursday. If the shortest distance that he ran on any of these 5 days is 5 kilometers, how far did he run in total? So let's start off with Monday, and let's call that X. Then on Tuesday, it would be 2x, since he ran twice as far. On Wednesday, he ran half as far as Tuesday, so we're back to x now. On Thursday, he ran half as far as Wednesday, so that's x over 2. And then finally on Friday, he ran twice as far as Thursday, so that is x. And they're saying that they want us to figure out that total. But we obviously will need to know the value of x. And that's where this sentence comes in. The shortest distance that he ran on any of the 5 days is 5 kilometers. The shortest distance looks like it's this guy, x over 2. So x over 2 is equal to 5, and therefore x is equal to 10. So now I can figure this out in terms of a numerical value. If I add all these guys up in terms of x, it looks like 1, 2, 3, 4, 5, 5.5x. And since x is equal to 10, that is basically 5.5 times 10, which is 55. So number 11, the answer is A. The point 0, 0 is reflected in the vertical line x equals 1. When its image is then reflected in the line y equals 2, the resulting point is. So here's 0, 0. And we are first reflecting that in a line of x equals 1. So I'll just write x equals 1 right there. So this is 1. And this line is x equals 1. So if I reflect this point into there, it basically will land on the other side. And that other side will be obviously 2, 0. Okay, so that's that first point. And then this point 2, 0, they're saying, is once again reflected, but this time in the line y equals 2. So approximately here. That's approximately y equals 2. So if you reflect this guy in y equals 2, it will end up somewhere here, approximately, which would be the same x coordinate, but the y coordinate would now be 4. So there you go. That's the answer to the question. So number 12, it's 2, 4, which is choice E. In the diagram, triangle ABC is right angled at C. Also, points M, N, and P are the midpoints of sides BC, AC, and AB respectively. If the area of APN is 2, then the area of ABC is. So let's label this. Since N is the midpoint of AC, from A to N will be the same as N to C. So I'll just call that A and A. And since M is the midpoint of CB, or BC, same thing, the distance from C to M is the same as the distance from M to B. So I'll call that B and B. So now they tell me that triangle APN has a area of 2. So APN, this triangle right there. Well, this is B, so this must be B also. And the area, therefore, is 1/2 base times height, which is B times A. And they tell me that's 2. So 1/2 AB is equal to 2, therefore AB is equal to 4. So that's the first part of the question. The next part, we have to figure out the area of ABC. Well, the area of ABC, that triangle, is again 1/2 base times height, but this time the base is the full length from B to C, and that is 2B. And the height this time is the full length, or the full height, from A to C, and that's 2A. So this becomes 1/2 times 4ab, and that becomes 2ab. Now a times b, we just figured out, was 4. So multiply 2 by 4, and you get 8. And 8 is the area of triangle ABC. So number 13, the answer is A. If 3 over x minus 3 plus 5 over 2x minus 6 is equal to 11 over 2, the value of 2x minus 6 is. All right, a little bit of algebra here. So 2x minus 6, 2x minus 6, what I'm doing is I'm getting a common denominator. And many ways to do this question. And same thing over here, x minus 3, like that. All over 2x minus 6. And that is equal to 11 over 2. All right? So this gives me, if I were to expand this, 6x minus 18 plus 5x minus 15. And the denominator, I'll just leave it for now, 2x minus 6 and x minus 3. And that is 11 over 2. Simplifying, you get 11x minus 33. And on the bottom, same thing. 2x minus 6, x minus 3, and that is equal to 11 over 2. Now, it looks like from the looks of this, I can factor, but first let me just cross multiply, and I can factor as well. I've got 11, and then from here I'll factor out a 2, and that's just become x minus 3, x minus 3. And then this guy and this guy, if I cross multiply those two, I get 2, but then I'll factor out an 11, and that gives me x minus 3. So the good news here is that a lot of stuff cancels. The 11s cancel, the 2s cancel, and one of these x minus 3s cancel. So all I'm left with is x minus 3 is equal to 1. So therefore x is equal to 4. And they want me to figure out the value of 2x minus 6. Well, x is equal to 4. So 2x minus 6 is equal to 2 times 4 minus 6. And that is 8 minus 6, which is 2. So number 14, the answer is A. In the diagram, if triangle ABC and triangle PQR are equilateral, then angle CXY equals. So here is this diagram blown up a bit, and I'll talk you through this. These are equilateral triangles, so that means they're all 60 degrees in terms of their angles. That's 60, that's 60, that's 60. This is 60, this is 60, and that's 60. All right? Well, all the angles about a line, if you add them up, are equal to 180. So that means this angle in here will be 180 minus 60 minus 75. And that is equal to 45. So this is 45 right here. And in a very similar way, all the angles about that line are equal to 180. So this angle in here is going to be 180 minus 65 minus 60. And that is equal to 55. So that angle in there is 55. Okay? So now I can figure out that angle in the same way. 180 minus 55 minus 45. And that is equal to 80. So that in there is 80. So now you have to understand that that's opposite to the 80, and therefore it's equal. Opposite angles are equal. And then finally, we get to the angle that we have to figure out, CXY. And CXY is this angle right here. Well, again, that's going to be 180 minus 60 minus 80. And that is equal to 40. So number 15, the answer is C. At Springfield University, there are 10,000 students, and there are as many male students as female students. Each student is enrolled either in the arts program or the science program, but not in both. 60% of the students are in the arts program, Also, 40% of the science students are male. To the nearest percent, what percentage of the art students are female? 10,000 students in total. They tell me that male and female students are equal in number. So that means we got 5,000 male, 5,000 female. Hopefully we will use that later on. So now immediately they tell me that 60% are in the arts program. So that means 6,000 are in the arts program. And therefore the remaining 4,000 must be in the science program. The next piece of information they give me that 40% of the science students are male. So 40% of 4,000 is 1,600. And those are the male students. And then the remaining science students, which is 2,400, must be female. Well, we know that the total number of female students at Springfield University is 5,000. So since 2,400 of them are over there, 2,600 of them must be over here in the arts program. And very similarly, since 1,600 are here in the science program, the other students that are male must be in the arts program, and that would be 3,400, like that. So this is basically the full table or full calculations of all the male, female, science, arts. So what do they want? What percentage of the art students are female? So art students, 6,000. And how many are female? Well, 2,600. So what they want is 2,600 over 6,000. And that, as a percentage, is about 43% approximately. So number 16, the answer is E. On an island, there are two types of inhabitants: heroes who always tell the truth and villains who always lie. 4 inhabitants are seated around a table. When each is asked, "Are you a hero or a villain?" all 4 reply, "Hero." When asked, "Is the person on your right a hero or a villain?" all 4 reply, "Villain." How many heroes are present? So this question is one of those that just requires some experimentation and what I call just sort of trial and error. So here we go. Let's see. They tell us that there's four inhabitants around the table. Okay? So if I put a hero here, a hero here, a villain here, and a villain here, let's see what happens. Now, like I said, it's trial and error. There's only a certain number of, possible ways of doing this in terms of the combinations, right? So, and obviously the answer choices help you with regard to which combinations. So you can go through each one and see what happens. So let's look at this. If this is the seating, and first question is, are you a hero or a villain? This hero says hero because all 4 say hero. If he says hero, he's telling the truth, which is what heroes do. This villain says hero, but that's a lie, which is what villains do. And similarly, it's the same for this hero and that villain. So the first part, that question is indeed consistent with this seating. Now let's get to the second question, which is the person on your right a hero or a villain? And all 4 reply villain. Let's see if that matches. When you ask this hero that question, he will reply villain. And he tells the truth, and that is the truth. When you ask this villain that question, he replies villain, which is not true, it's a lie, and that is consistent with being a villain. And the exact same thing holds true for this hero. He is asked, the person to your right, is he a villain or a hero? He says villain, since all 4 reply villain, and he is telling the truth, which is consistent with what heroes do. And finally, this villain replies villain, which is a lie, which is consistent with what villains do. So this scenario matches the criteria or the answers of the question stem. And therefore, that means there's 2 heroes and 2 villains. So number 17, the answer is C. There are a certain number of red balls, green balls, and blue balls in a bag. Of the balls in the bag, 1/3 are red and 2/7 are blue. The number of green balls in the bag is 8 less than twice the number of blue balls. The number of green balls in the bag is. So the first piece of information they give me that the number of red over the total, which is R plus G plus B, red, green, and blue, is 1/3. The next piece of information is that the number of blue over the total, which is R plus G plus B, is 2/7. Okay? And then the third piece of information is that the number of green is equal to twice the number of blue and 8 less than that. So these are the 3 equations that they give me, and I have to somehow use them to figure out the number of green balls. So here we go. From the first one, this guy right here, I can cross multiply, and if I do, I get 3R is equal to R plus G plus B. Okay? So, let's see here. So, I can bring the R over, I get 2R, and I get G plus B. And I've got 3 variables in here, but I can use this to simplify a little bit. 2R, G is equal to 2B minus 8. So, I'll put that in, plus B. So, that gives me 3B minus 8 is equal to 2R. All right, so far so good. I don't know if that's going to help, but we'll see. The next one, if I cross multiply, I get 7b is equal to 2r plus 2g plus 2b. Simplifying this, collecting like terms, I get 5b is equal to 2r plus 2g. And again, I know this, so I can substitute that in for g. And if I do, I get 5b is equal to 2r plus 4b minus 16. And therefore, b is equal to 2r minus 16. All right, let's see where else I can go. Well, continuing with this, 2r right here, I know is 3b minus 8. So I'll just substitute that in, 3b minus 8 minus 16. And then collecting like terms, 2b is going to be 24, and therefore b is 12. So a little bit of manipulation, we got b equal to 12. Now they want us to figure out g, so substitute b back into this equation, and I got 2 times 12 minus 8, so that's 24 minus 8, and therefore g is equal to 16. So number 18, the answer is 16, which is choice B. In the diagram, the 4 coordinates are 0, 1, 1, 3, 5, 2, and 4, 0. What is the area of quadrilateral ABCD? So the first thing I'd like to do with this diagram is make it into a shape that is most likely a rectangle, like this. And when I do that, what I can do is subtract from this rectangle these 4 triangles that have been created, and if I do that, I'll have the area of the quadrilateral. So to summarize, first we'll figure out the area of this big rectangle, and from it I will subtract the 4 triangles, those ones right there. And if I do, the remaining area will be the area of ABCD. So here we go. ABCD is going to be the total area minus the 4 triangles. So here we go. First, of course, we have to label this. And the good news is they've given us a lot of this already. 0, 1 is here. B is 1, 3. C is 5, 2. And D is 4, 0. So here we go. 5 is here, since that's 5, 2, and this is 3, since that is 1, 3. So this coordinate right here is 5, 3. So that basically tells me that the dimensions of that rectangle are 5 and 3. So immediately the total area, this T right here, is 5 times 3. So that's the first. Now I've got to figure out each of these triangles. So I can start anywhere really. Let's just start here. That one, the base is 4 and the height is 1. So it's 1/2 times 4 times 1. Okay? So very similarly, I'll do that for all the other ones. This triangle right here, the base looks like 1 and the height is 2. Right there. I'm getting that entirely from the coordinates. So again, 1/2 times 1 times 2. 1/2 base times height. This triangle is next. And let's see here. The base looks like 1 and the height is 2. So 1/2 times 2 times 1. And then finally this triangle, the base, we are going from 1 to 5, so that's 4. And then this height, we are going from 2 to 3, so that's just 1. So 1/2, 4 times 1. All right, so here we go. So that's going to be, this guy is 4 divided by 2, so that's just 2. This is just 1. This is 1. And this is 2. So this gives me 15 minus 1, 2, 3, 4, 5, 6, and therefore that is equal to 9. So number 19, the answer is A. What is the largest integer, n, for which 3 times n to the power of 2007 is less than 3 to the power of 4015? 3n to the 2007 is less than 3 to the power of 4015. Well, the first thing I'd like to do is get rid of this 3 here. And I can do that by breaking up 4015 into 1 and 4014. It's perfectly allowed to do that. And if you do that, you do indeed get rid of those 3's. So now you're just left with n to the power of 2007 is less than 3 to the power of 4014. Now, 4014, I immediately notice, is exactly double of 2007. So I can write 3 to the power of 2 all to the power of 2007. That is perfectly allowed. And this is n to the power of 2007. So n to the power of 2007 is less than 9 to the power of 2007. So there we go. This is what we've boiled it down to. And if you stare at this, the largest value for n, well, n obviously is less than 9. So the largest value of n less than 9, that is an integer, is n equal to 8. So number 20, the answer is D.